Well, hi guys. We are going to look at a specific kind of sequence for tomorrow, and it's called an arithmetic sequence. And before we do this, we're going to give our shout out to Demir. Demir, you're being inducted in the National Honor Society tonight, so this is an appropriate time for your shout out. I realize other people are as well, but today's Demir's shout out. So there you go, brother. All right, so we're going to look at a specific kind of sequence, and for tomorrow, we're going to need to know a couple of formulas and a couple of ways to approach these. And so we're going to deal with arithmetic sequence. So let's take a look at what I mean by arithmetic sequence. An arithmetic sequence has something called a common difference. In other words, we are adding or subtracting the same thing every time. And so what we're going to look for is we're going to look for any two terms, and we're just going to subtract the two. And so if I have like 7 to 11, then that is simply 4 more. And then you got to make sure that it continues that pattern. So we're doing plus 4, and then we do from 11 to 15 plus 4 again. So it's a pretty easy pattern. The next one is 19, and then it'd be 23, and then 27, and then 31. This is called an arithmetic sequence, and we're going to say this common difference, I'm going to call that D, is 4. Number 2, the next terms here would be negative 10, negative 12, negative 14, and negative 16. And here we're subtracting 2 each time. That's still arithmetic, so we're going to say that common difference is negative 2. And for this third example, we are subtracting 8 each time. So this would be negative 9, negative 17, negative 25, and negative 33. And here we'd say our common difference is negative 8. So an arithmetic sequence must have a common difference between any two consecutive terms in your sequence. Now what we're going to do here is we're going to look at this term a sub 1. And the a sub 1 is the very first term that you see. We know that from dealing with sequences the last couple of days. And so if you know the first term and you know the common difference, then you should be able to find the next terms after it. So if the first term is 6 and the common difference is 9, this means we're going to add 9, and add 9. So let's just see what the next terms would be. Add 9 to 6 is 15, plus 9, and plus 9. So that's how you generate an arithmetic sequence. You can find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 just by adding 9 each time. And again, if we started with negative 60 and we had a common difference of 4, we would add 4 each time. So if you know the first term and the common difference, you can generate your sequence. Okay, so what we're going to want to do whenever you're writing the equation for the nth term, which is going to be something a little harder, is the first thing you want to do is find a sub 1. After you find the first term, then you want to find your common difference. After you do that, you want to plug in values into this equation right here, and this is the equation you're going to need to use. A sub 1, n, and d, and a sub n. Then we'll distribute the d, simplify by adding terms, and we have an equation to find any value in the sequence. Let's practice this. So I've got 18, 25, 32, and 39. So on this problem right here, a sub 1 is 18. Now what is my d? Well, it's 7 because 18 plus 7 is 25, 25 plus 7 is 32. So my formula is a sub n equals a sub 1 plus, and let's go back and look at that formula. Pull that up there. N minus 1 times d. So n is going to stay n. And in your book, I think they might even put d in front. I'm going to put the d in front. D times n minus 1. So for our example here, a sub n equals a sub 1, which is 18, plus the common difference, which is 7, times n minus 1. And we can distribute our d. So that's 18 plus 7n minus 7, collect like terms, and we get that our 18 minus 7 is 11 plus 7n. And that's what we have there, 7n plus 11. Notice that's written like in mx plus b form. That's the same thing as this. So let's do that again. First thing we want to do is we want to find our a sub 1. So a sub 1 here is negative 14. Our common difference, what are we adding each time? Well, we're adding 9 each time. So the a sub n would be a sub 1 plus the common difference times n minus 1. Go ahead and distribute. And then collect like terms, and we're going to get 9n minus 23. So let's see if we got that one right. There we go. So I'll leave that third one up to you to do. So what if we wanted to find a specific term in the sequence? For example, what if we wanted to find the 9th term, or the 14th term, or the 100th term, or whatever? So what you can do is you can write your equation a sub n equals a sub 1 plus d times n minus 1. Go ahead and clean that up into a sub n equals, that's 6n minus 6 plus 4 is 6n minus 2. Find your nth term formula, so a sub 14 would equal 6 times 14 minus 2, which that is 82. Let's see if we got that right. There we go. The rabbit says it's 82. So that's what you're going to be doing tomorrow, is you're going to be finding like the general term formula, and then sometimes finding specific terms in the sequence, or the first 5 or whatever. So a sub 1 and d are important. Find your equation, and then you can do anything with it. All right, that's it. I will see you guys, some of you tonight, and for NHS induction, and the rest of you, I'll see you tomorrow.